Hello, and welcome to the Los Angeles Geospatial Summit. My name is Isaiah Mack. I am a gold level sponsor, and I am here representing EOS Aero GNSS and Eclipse Mapping and GIS. I have been in the mapping and GIS business for nearly 20 years now, ever since graduating from USC Geospatial program back in 2002. I am happy to introduce Tyler Gackstetter, the presenter of today's workshop titled Survey Accurate Data Collection on Your iPad Using Esri Collector. Tyler is a friend and colleague of mine who has been working heavily with high accuracy Esri workflows and high accuracy GNSS for many years. Tyler's expertise in this area is second to none, so please enjoy the presentation and please feel free to follow up with Tyler or myself with any questions after the workshop.
During this session, we're going to look at how to publish a web map for use in Collector and optimize it for high accuracy data collection using an RTK or submeter GNSS receivers. There's a few tips and tricks in order to collect not only accurate data, but metadata associated with your positions to have a record of accuracy, quality, and that kind of information. So we're going to go through how to publish a layer two separate ways. First one is going to be using Arcgis Pro on the desktop, and the other way is going to be actually creating a layer directly in the browser in ArcGIS Online. Both work just as well. I would say that ArcGIS Pro allows you more functionality, and it's more kind of the standard GIS way to create the layers and publish them to ArcGIS Online. But if you're just getting started and you want to make a layer really quick, just quick and dirty and get out in the field quickly, then you can definitely utilize some of the features in ArcGIS Online within the browser to spin up a layer and still capture high quality 3D GIS data with the GNSS metadata fields. So let's get started and let's look at how we create a layer in ArcGIS Pro first. Okay, so here we have ArcGIS Pro. I've already signed into my organization, as you can see up in the top right. And I've already opened up a blank template, which is just the standard map template in ArcGIS Pro. If you haven't used Pro before, this workflow is pretty similar to what it's going to look like in ArcMap, although ArcMap wasn't really optimized for ArcGIS Online, so it doesn't work quite as well with it, but all this is definitely doable in ArcMap. First thing we need to do is we need to create a feature class in a file geodatabase, and then from there we can add fields and customize it before we publish it to ArcGIS Online. So in ArcGIS Pro, every project has its own geodatabase. If you go over in the catalog on the right-hand side, expand the databases section, and you'll have a geodatabase that's named the same as your project. So in this case, my project is GIS Workshop, and we have an empty geodatabase. To create a feature class, I'm going to right-click on it, select New Feature Class, and that's going to open the wizard in ArcGIS Pro for creating a feature class. First thing it asks for is its name. In this case, I'm just going to name it a point. And I'm going to change this feature class type from a polygon to a point. And this is an important part down here. Is there's the Z values. Now in ArcGIS Pro, it's defaults to on, meaning it's checked. And I would highly recommend keeping it that way, whether you think elevations are important to you. They may not be important to you now, but they may be in the future. And you have all of the tools available to you to collect that data. So we might as well. You can always collect, you can always collect a lot of information and not use it in the future, but you can't go back and collect it if you didn't. So keep that checked on. And also any of you that are using ArcMap, note that this is not the behavior in ArcMap. ArcMap actually has Z-values disabled by default. So make sure you find that setting in there and check that so Z-values are turned on in your layer. If they're not turned on, that data will just disappear. It won't be captured at all. All right, next it's asking for the fields we want to add. Now you can either add them right now or you can add them later after we finalize the feature class. You can go in and edit the attribute table. It's up to you. In this case, since this is just a demo, I'll create a few basic fields such as ID and notes, kind of my standard go-to fields for generic layers, both text fields, and yeah, we'll just keep it simple and leave it at that. So I'm hit next, and spatial reference. This one is, in ArcGIS Pro, it's going to default to this WGS 1984 Web Mercator auxiliary sphere. that matches with the Esri base maps that are used not only in Pro, like the one you're looking at here, but in ArcGIS Online. And in ArcGIS Online, you're kind of tied to that coordinate system unless you upload your own base maps and your own coordinate system, such as state plane or UTM. So if you don't know, if you're not sure that you're using your own base maps, I can pretty much guarantee you that your maps are going to be using this WGIS 1984 Web Mercator. And it doesn't mean you have to publish in that coordinate system, but say even if I publish this in state plane, if I bring that into a map in ArcGIS Online, it's going to operate in this WGIS 84 Web Mercator. It'll just kind of handle that transformation mostly seamlessly. But just know, just because I publish this in state plane or some other coordinate system, it's not going to necessarily use that coordinate system in the map. Like I said, you'd have to upload your own base map in order for it to work that way. And Collector does support that. I mean, you can definitely set up Collector to operate completely in state plane if you do upload that base map. So to keep things simple, I'm just going to leave this here as a default and move on. All right, tolerances, yeah, we'll keep all these default. Finish. And this should create a just very basic bare bones feature class with those two fields that I added, the ID and notes, as a point Z layer. So meaning it's a point feature layer with that will capture Z values. And that is it. Back to show you, I will bring up the fields. And you can see we just got a basic object ID, shape field, ID, and notes. Now, when we're capturing data using high-accuracy GNSS receivers, or even if you're not using a high-accuracy GNSS receiver, there are additional fields that Collector will recognize and populate data with that will give you more information about how your position was captured, which is very important when looking back at historical GIS data so that you have an idea of its quality, accuracy, and kind of situation, how that was captured. And so Esri has designed Collector to look at these very specific field names, and if those field names exist, then it will automatically populate those variables, those values, into those fields without the without it showing up in the form or anything. It's very seamless. So how do we add those fields? Well, there's in ArcGIS Pro at least, there's a tool in the toolbox that will automatically append all of the fields available to you. If you don't want to capture all of them, you can always delete them later. But I highly recommend adding all these fields and leaving them there because they don't take up much space, and some of this data is invaluable and will be very useful looking back on this data in the future. So where do we find that? Well, let's get out of this fields menu and let's go to the Analysis tab, click on Tools. And the great thing about Pro is I can just search my whole toolbox. So if I type in GNSS or even GPS, I get this Add GPS Metadata Fields tool. I click on that. As you can see, it's a really simple tool. It's just asking for the input point feature layer, and select that layer, hit run, and it'll automatically append those fields. Now, the reason it says input point features is because this will only work with point feature layers. Right now, at least, there is no way to capture all of this GNSS metadata for lines and polygons. And it's a little bit more complicated to do it that way. I probably require a related table of some sort, but just know that that's a limitation. So this will only work with point features. So let's hit the Browse button, and let's go into our Geodatabase, select the point layer. Where's my OK button? There it is. Click OK, and run the tool. Usually just takes a few seconds or so. And like I said, this is just appending a preset kind of table of fields to the end of my feature class. So I definitely recommend running this after you've added all of your other attribute fields that you want to collect, or else it kind of get mixed up in the middle. All right, let's exit that. Now that's done, and let's take a look at this table again. All right, so now you can see we've got, these were the 4 fields that were originally there, and that tool has added all of these fields below it. We've got position, source type, receiver, latitude, longitude, a bunch of them. And most of these fields won't be populated if you're not using a high-accuracy GNSS receiver. But still some of them will be, like even if I collect a point using my phone, like receiver, position, source type, estimated accuracy, depending on the device you're using. So anyway, it's just good to keep all of them. And it only took me 5 seconds to add those fields, so it's really not an expensive process. Okay, now that we've got those fields in, let's exit out of here. And we are ready to publish our layer to ArcGIS Online. There's a couple different ways you can do that. I know some of you have probably been through this before and already have your own workflow dialed in. For those of you who haven't, if you go to the Share tab, you can either publish this as a standalone layer, or you can actually publish the entire web map. I prefer, depending on the situation, but most of the time I prefer to publish this as a standalone layer. That way I can add it to a web map and customize how it's used and displayed in that specific web map for a specific purpose, whether that's for Collector or a web app or something else. So I opt for choosing the web layer. All right, so here's sharing as map web layer wizard, and we need to name this layer. So keep in mind that this web layer can contain multiple layers in my table of contents. So the name here should represent all of this whole table as a whole. Even though we only have one layer right now, most of the time you'd have multiple layers. So this would be like GNSS. Let's just do GNSS point layer. And yeah, summary and demo. Got to have your tags, remember that. And this is going to be a layer type of feature that stays the same. You can choose to put it in a different folder if you'd like, and you can choose who you share it with at that time, or you can configure that stuff later as well. You don't have to do that now. Before you just publish from here, there's additional options that we want to set. So if you come to the configuration tab and under this feature, click the pencil, and we need to enable editing. Collector will not recognize any maps that do not have an editable layer associated with it. So that was a pretty common thing, a common question that I got, at least in years past, was, I went through this whole process of uploading this layer and making this web map, and it won't show up in Collector no matter what I do. And people sign in and out and refresh and all that, but never show up. Well, it's because that layer wasn't editable. So even though you added it to the map, Collector will only show you maps that are either shared with you and have editable layers. So make sure you check that. It can be modified after the fact once it's published, but it's easier to just enable it now and forget about it. Also, these two options enable sync. This allows users to take their map offline. So that can be important. And export data will allow other people to export the data to CSV or File Geodatabase or Excel in Arcgis Online. So I like to turn those on too. All right, so before we publish, it's always nice to analyze it, have Arcgis Pro go through it and tell us if there's anything missing or not set up right. In this case, I got a couple warnings which don't matter. Feature template sets are created automatically when you publish it, and layers data source not topographic, that's not going up with the feature layer. So we're not publishing the web map. So we're good to go. So let's hit publish. And it'll take usually less than a minute for something this small. Looks like it's almost done. There we go. All right, successfully published. We got the green box. Excellent. So now let's switch over to the browser. And here I've already signed into Arcgis Online under the same username as I did in Pro. And so let's go to My Content. And we can see our GNSS point layer right here. Now, this is just a layer hosted in Arcgis Online, but it's not associated with a map or anything. And Collector does not recognize just layers on their own. It has to be part of a map, web map that is, and saved and shared with whoever you want to access it. So to add this to a map, there's many different ways you can do it in Arcgis Online. You can either click this map tab, start a new map, and then search for the layer, or you can click these three dots next to the layer and click Add to Map. Well, they're the main two, but there's others as well. So let's do it this way because I find this easier. And it's going to ask me how to display the style. I'm just going to keep it simple. And let's just cancel. There we go. So I've got this map. I've got my layer in here. I can even rename it if I want. GNSS point layer. Just name it point. And first thing I do before I even start changing stuff is I just save this map. So let's just call this GIS demo. Tags, demo, I don't need a summary, and I'll save it. Oh, all right, we'll do a workshop then. Okay, so now that we've got that, we've got our layer in our web map, and really at this point I could pull up Collector. I would see the map in there, open it, and I can start collecting data in it. A couple things I like to do before that are, one, choose your base map if you don't like this one. So I'll go imagery with labels. Tend to prefer that one. And then the other important change specific to the GNSS receiver is to display Z values. Now, Collector does not display the Z values in the pop-up by default. So I need to go in here and configure the pop-up. And I'm going to use a little arcade script to pull that Z value out and display it in the attribute table. Now, this is not going to add it to the attribute table. It's not going to persist in the attribute table at all. If I export this layer, this field will not be included in there. But it's kind of an on-the-fly calculation so that at least in the field, when I capture a point, I can look at the Z value or elevation. So to do that, I'm going to go down to these attribute expressions, click Add. And I'm going to change the title of this field to elevation, and this is going to display elevation in meters, which is the default way to describe the elevations in the Z value. They're always going to be in meters. I'm going to clear this out, and I'm going to type in geometry $feature.z. That function right there, geometry, will pull the geometry of our feature. This is referencing our feature, and we're pulling the Z value from that geometry. Now this will return a big long string of numbers. It's basically will have a precision after the decimal point to like 13 decimal places. So I want to round that down to 3. So I'm going to wrap this in a round function, specify 3 decimal places, and be done. Hit OK. Now, for those of you that don't want to look at the elevation in meters, you can easily calculate this into feet using Arcade as well. So let's hit Add. Let's do another one called elevation, but with feet this time. Leave this out. Now we're going to do round geometry $feature.z times 3.28084, which will get us to feet, and round that to 3 decimal places. Okay, perfect. Hit OK. So now we've got our 2 Arcade expressions pulling the elevation out. We've got our, let's see, all of our GNSS attribute fields in there. Perfect. Another quick tip is that these fields, these values, are displayed kind of like a little weirdly at first, at least by default. So like PDOP is typically a, it's got 1 decimal place. And you can see if I click on this, it's trying to put it out to 6 decimal places. So I do like to come in here and let's just start at the top. Let's go latitude, longitude. I want that out to 8 decimal places. Longitude 8, altitude 8, or sorry, 3. Horizontal accuracy 3, vertical accuracy 3, and correction age usually in seconds, so I just do 0. That's usually okay. PDOP, let's do 1. Step 1. Step 1. Okay, that'll do it. Hit OK, and save the map. And that should give you a map that's usable in Collector. It will capture all the GNSS information and pull out the Z values and display it in the pop-up. Okay, so that's using Pro. Now we're going to look at how to just create a layer directly in ArcGIS Online. This is much faster, but you have less control over the layer. So let's go back to our content. And let's go to create feature layer. And then what you'd want to do generally is you go to build a layer and you start from a blank point, line, or polygon layer, in this case point layer. The problem is that the Z values aren't enabled in this layer. So to get Z values, I found one of these templates in here. It's actually the drone template. Does include Z values. Sorry, it's not drone, it's ground control. Oh, sorry, show all. There you go. Yeah, you can search ground control or drone, actually. If you use this one, it includes Z values. And so yeah, you don't have to worry about that because there's no way to enable Z values after the fact. So you need to choose a template that has them already enabled. So I'm going to select that. hit create. Ground control, I can also rename this here. Just do point. And then here's a trick, is just check that box that says capture GPS information. That will automatically add all the fields that the tool did in Arcgis Pro, that add GPS metadata fields tool. This will do all that work just with just that checkbox. Hit next. Set that, name my layer, GNSS point, like AGL, since it's created by AGL. Hit done, and that creates my layer. So now, once that's done, I can pull that into the same map. I can add my my pop-up configuration so that the z-values are displayed, and modify it, modify the symbology however I want, and basically will be the equivalent to what I just did in Pro. So that's pretty much how we've got our 2 layers set up. Map is ready to go, so I'm going to go outside and I'm going to demonstrate how to collect some features in Collector using these web maps and layers that we've just created.
Okay, now that we've created our ArcGIS layers and published that to a web map in ArcGIS Online, we're ready to capture some data out in the field using our GNSS receiver. So today I have an Aero Gold RTK receiver connected to our RTK base station here at the office, and I have an iPad mini running ArcGIS Collector, and we're going to look at first how to set up Collector so that it can talk to the RTK receiver, and then we're going to go through the workflow of how to actually capture features in Collector with high accuracy, including points, polygons, and lines. So first, what we need to do is we need to open up Collector and sign in. Now, I've already signed in, as you can see. So the next order of business is we need to tell Collector what position we want to use. By default, Collector is going to use the integrated receiver in this iPad or your iPhone or whatever device you're using. And that's not very accurate, right? We have this RTK receiver that can get us centimeter grade accuracy. So we need to let Collector know that, hey, I want to use a position from this device, not the iPad. So to change that, we need to go to the main menu of Collector, which you get to by tapping this icon upper left. And it brings up the Collector profile, which is the main settings. We're interested in the location, so scroll down to location category, and we want to change actually 2 settings here. First being the provider, and that's where Collector is going to get its position from. So as you can see, the default right now is integrated. We tap on that. It's just the integrated GPS receiver in this iPad, not very accurate. We want to add, which is in this upper right corner, add our RTK receiver. And what this is looking at is just any devices that are connected to your iPad via Bluetooth. So I've already Bluetooth paired my Aero to this iPad, so it shows up in this list as an available location provider. I'm going to tap on add, and then it's going to ask me for an antenna height. Now, depending on your setup, you may have an antenna height of 0, could be 2 meters, could be more precise than 2 meters, say 2.034 meters to get the best vertical accuracy. Just kind of depends on the ergonomics of your setup. Now, in this case, I've got my Aero Gold mounted on top of a 2-meter range pole, and I actually know the exact antenna height happens to be 2.034 meters. So here, I'll punch that in, 2.034, and what that's going to do is it's going to calculate out the length of this pole so that all the positions I capture are not going to be here at the antenna where it receives the satellite signals, but it's going to be at the ground level where we want to actually capture the position of our asset. So I'll punch that in, I hit done, and then remember to check to see where this blue check mark is integrated, even though I added my my Aero as the location provider. So tap on it again, and now you can see that blue check mark has moved down, and Collector is now using my Aero RTK device as the location provider. Now the next thing that we need to check, and this depends on what kind of receiver you're using, is the location profile. The location profile in Collector is used to convert or transform your coordinates from one datum or coordinate system to another. So in most cases, say if you're not using an RTK receiver, say if you're using an integrated receiver in your iPad, all of those coordinates are going to be reported in WGS84. And that's just by default, which most receivers are outputting in. And so if you're using one of those devices, such as internal iPad 1, you can leave it default and you'll be fine. Now, when you start getting to the high precision level of the RTK receivers, usually the reference stations that they're getting these corrections from are referenced to a different datum than WGS84. And the difference between those datums can be significant. In my case around here, it's about 1.5 meters. So what that means is that if I don't change this location profile and I go and start collecting data, I may want to capture the location of this bush right here, but what the coordinates coming from receiver are going to be 1.5 meters different from the WS84 datum. And so if I want to capture the bush there, my position would actually end up here. And if you leave that as the setting and you actually go capture some points or go sit on a curb, you can actually see that in the imagery and see that difference. Some of you may have experienced that issue and didn't know how to solve it. And that's what this is for, is a location profile. The good news is that the majority of the reference stations for RTK are all on the same datum for the most part. And that is NAT83 2011. And so our RTK base is referenced to that. So I'll show you how to set up the profile. Actually, just real quick before I add the new one, let's look at the default. So let's click information button. And of course, you can see what I said is it's assuming your coordinates are in WGS 1984. We want to change that. So let's hit add. And it's going to walk us through this wizard. It's basically got 3 criteria. First is going to be the GNSS coordinate system. So you need to tell Collector which datum the coordinates coming from the receiver are in. In this case, it's NAT83 2011. So I can use the search function, type in 2011, type in NAT83 2011 there. And then it just moves on to the next option. The next one is map coordinate system. Now, for ArcGIS Online, if you're using the default ArcGIS or Esri base maps, those are all going to be in a specific coordinate system. This WS84, Web Mercator, Auxiliary Sphere. If you uploaded your own base maps or own imagery in a different coordinate system, then you would use that coordinate system in here instead. But most people that I've worked with or run into are using the default Esri base maps, and so they're going to be using this one, WS84, Web Mercator, Auxiliary Sphere at the bottom. Now, there's duplicates of almost everything here in this list, so it doesn't matter which one you choose. Just make sure it has that auxiliary sphere at the end. This part is going to determine what datum transformation we choose to get between those 2 coordinate systems. So if you just click this arrow on the top right while you're tracking and got a position outside, it'll take you right to the position where you're at, and it will choose or at least order the list on the next screen the best datum transformations in your area. So I tap that, hit next, and then it gives us a list of these datum transformations, and the one at the top being the best one for where I'm at currently. So if I fly, across the world or the other side of the country, it could be different. But as long as you use this feature where you get your current location and choose the top option, you should be okay. Of course, if you want to make sure you have the best accuracy possible, it's always recommended to go hit a benchmark or a control point of some sort to test the accuracy. All right, hit done. I got to name the profile. Let's name it RTK. And then again, with the blue check mark, make sure it is selected. So those are the 2 options that we want to set. As long as those 2 are set, you should be okay. The rest of these settings here are mostly personal preferences. One that I get a lot of questions about a lot is accuracy. That's not actually going to change your accuracy at all. It's just setting a threshold so that if your estimated accuracy is above that, Collector will give you a warning and say, hey, your receiver is not giving me under 5 centimeters or under 2 centimeters. Or under 5 feet, or whatever your requirement is, and do you really want to capture that position? All right, now that we've got all of our Collector settings configured, letting Collector know to gather its location from the RTK device and to use location profile to get rid of the datum shift, we're ready to capture some features. So let's take a look at what that workflow looks like in Collector. First thing we're going to do is exit out of our settings menu, and then we're going to look for our map, which is the top map for me, GIS demo. And then the first thing we're going to look at is at the top, right below the title, where it says GPS accuracy. As long as I've got a value that Collector's getting the data from my GPS receiver, 2, that it's got a valid GPS fix, and 3, that it's got decent accuracy, or at least the accuracy that I'm looking for. So in this case, my accuracy is 0.1 inches because I'm connected to my RTK base station here at the office, and that is what I want. That is what I'm looking for. I feel confident in that, and that I'm ready to capture features. If I want more information, I can tap on that like I just did and open up this pop-up that gives me more information about my receiver's position, such as my altitude, horizontal and vertical accuracy, fixed type, and then information about my base station. So if I'm ever having issues getting a fix or I need to troubleshoot my GPS receiver, I can open that up and it can give me a little bit more information. So to start capturing features in Collector, you're going to tap the blue plus sign. Now, there's an important piece of information to know before or when you start capturing your features. So this device is a very precise instrument, and it captures GPS information within a couple centimeters. Now, that's only going to do that if I use it properly. And part of that process is knowing when Collector is actually capturing the position from this receiver and storing that information for the feature that I want to capture. So Collector works by, as soon as I tap on this layer from my ground control point, it will capture the position of my GPS receiver where it's at that moment. Now, most people aren't ready to capture that position when they tap on that layer. But that's not the only time you can capture the position. We have an opportunity to update that information before we actually submit all the information for the receiver, or for the feature. So my workflow in Collector is I'll tap on the layer, and I won't care where my receiver's at the moment. You know, if I'm using this pole, I can be, you know, it's not over the asset, it's not bubbled up or anything. I'll just tap on the layer. I'll come in and I'll fill out my form. So I can tap on these fields and say, you know, control point ID 1, note is test. Name is test. I can take my photo. And it's still using or assuming that I'm going to use the coordinates from when I first tapped on the layer. But I want to actually update that point after I've gotten my pole, you know, positioned correctly and bubbled up correctly. So let's say I'm going to capture the position of that bush. Now I can take it out of here. I can go and position the pole on the actual bush, make sure that my bubble level is bubbled up correctly, and then tap update point so that recaptures its position now that I'm here, you know, ready, bubbled up, and plumb. And after that, after I press the button, I can move it wherever I want. I can put it back in the stand here, and that you can see that red dot still stays at the same point in that bush. And so say I could, you know, update the photo. And then I could submit this point. And to show you guys the precision here, we can actually capture a couple more of these bushes that are pretty close together. So if I hit this plus sign, I can go occupy this bush now. Remember, bubble up, hit update point, submit, move over to this guy. Plus sign, point, bubble up, and submit. And we can see those 3 points are, you know, I was just at the edge of the bushes, but you can see they're only about a foot or so apart, and you can clearly, you know, show the distinction between those 3 bushes. Now, let's look at some more information that's captured with each one of those features, and that's the GNSS metadata that we talked about earlier, and we showed how to set up for each one of your layers. If you click on each one of these points, they each contain this receiver information towards the bottom, starting with position source type. So position source type is showing that it's an external GNSS receiver, which is the Arrow RTK device we're using, as opposed to the integrated receiver or an iPhone or something like that. You can even get more specific at the receiver name field. It says EOS Positioning Systems, so I know I was using the Arrow device, and the serial number, so I know specifically which device I was using. Say if you've got a fleet of a few or a handful of them, you can either tie it back to that device or even a specific person that was using it. The next 2 fields, we got horizontal accuracy and vertical accuracy. These are very important because if you look back a year from now at the point that I just took, if I just had a latitude and longitude, then I wouldn't really know how accurate it was at the time. You know, I couldn't remember which equipment I was using, if I was connected to an RTK network. There's a lot of different factors that go into getting a precise position. So having an estimated accuracy, I can go back and say, hey, okay, this was clearly captured with an RTK device, and there's no need to necessarily update that point. I'm pretty confident in its quality. We've got latitude, longitude, and altitude fields. Now, these aren't to be confused with the geometry of the feature. So in this case, the point that we captured, if you look at the top of the pop-up underneath GNSS point next to that red dot, you see, a latitude and longitude in decimal degrees. That is going to be different than the latitude and longitude in this attribute table. Now, because this map that I'm using is WGS84, the latitude and longitude in the geometry of the feature is going to relate back to the WGS84 datum, whereas the latitude and longitude in this attribute table is going to be in NAT83 2011, which is what the correction source for our GPS is. So if you get confused and you compare those 2 sets of coordinates together and they're not matching, well, that's the reason why. They're not supposed to be equivalent. The idea is that the latitude and longitude here are the raw coordinates coming from your receiver before the transformation that's applied by the location profile. So if you ever need to transform it to a different coordinate system or different datum, you can start at the source rather than taking the already transformed coordinates and transform them further. Altitude, this is always going to be your height above ellipsoid value, whereas which is kind of the raw GPS height, whereas the Z value in the feature is going to be your orthometric height or mean sea level height reported by the receiver. So in that one, if we're going to skip some fields here for now, we'll come back to them. But if we scroll down to our elevation fields, the ones we made for meters and feet, those are the values pulled directly from the Z value of the feature, which are supposed to represent mean sea level or orthometric height, just depending on how you've got your receiver set up. And that is the Arcade script working to basically just query the Z value from that feature and either just display it like in the case of meters, or with the feet field, we are multiplying it by that factor to get from meters to feet and displaying it here. So the rest of these fields, we've got your PDOP, HDOP, and BDOP, which anyone who's used GPS, in the last few years or 10 years ago, that was kind of the values that you looked at to determine the quality of your points, which I really isn't used much nowadays because we've got so many satellites up there. Your PDOP values are rarely high, but still a good thing to capture. Fixed type is an important one. That is the kind of classification of your point. If you're using a sub-meter receiver, that would normally be a differential GPS or DGPS. But if you're using RTK, you want to look for RTK float or RTK fixed, which is what we've got in this case. A correction age of 2 means that my receiver was getting a correction at least every 2 seconds at that time, which is satisfactory. Our station ID is the ID of the station I'm connected to, which is the one here at our office. And of course, we got our number of satellites used and the fixed time. The 4 blank fields below that are only going to be used if I have averaging turned on. And that is a setting available in the collector settings menu where we set up location provider and location profile. Some people like to use it more so when it's a sub-meter or like a consumer grade GPS, just to squeeze a little bit more accuracy out of it. In the case of RTK, I don't recommend using it. One, because most of the time these GPS receivers are, if you're doing RTK, your point's bouncing around within a couple centimeters, maybe a couple inches. It's really just kind of almost a waste of time to sit there for 10 seconds, 20 seconds, 30 seconds, especially if you're collecting a lot of data in one day. You need speed. The other reason is that while you do get these four fields populated, a lot of these other fields will not be populated if averaging is turned on. So PDOP, HDOP, VDOP, your horizontal accuracy, your fixed type, your number of satellites, all of those will be blank because it doesn't really make sense to average those over time. It'd be weird to have like a number of satellites of 23.2 or something, which is what you get over averaging number of satellites in a session. So just know that everything's probably working fine, even though if you see some fields missing, if you've got averaging turned on, that's expected. All right. So now that we've captured 3 points, we've looked at our GNSS metadata fields. We know how to capture that, know how to read it. Let's look at the other feature types that we can capture. Which, in GIS, basically, you've got 3 feature types. You've got points, lines, and polygons. So let's look at a line. And there's a few different ways that you can draw a line with your GPS in Collector. You can either add vertices one at a time, or you can stream your GPS and you walk around a feature, walk around, say, a curb or an island or something like that. So it just kind of depends on what you're doing. Let's just take one real quick, and we can do this curb around these bushes. So line, let's just do the vertices. So I'll start maybe in this corner. Again, you can bubble up, then hit add point, and then go to the end here, bubble up, add another one, and just keep doing that to kind of draw this feature. All right, then we can submit, and let's take a look at what this data looks like. I know I didn't draw it perfectly, but what I really want to highlight is the fact that we don't have the GNSS metadata information with this line. So it's really just capturing, the length of the line, any additional fields that you add to it, your attribute data, such as, what the line is about, what kind of, what's it representing. But with lines and polygon features, you cannot capture that GNSS information such as estimated accuracies, a number of satellites, and that all that good stuff. So a lot of the time, what people will do is they will capture just individual points, like I just did. Capture the points in a point feature class, and then later in GIS they can draw the lines in between them, just so they have a record of that GNSS information. It is a limitation also, but know that even though you don't have the GNSS metadata information, all the Z values will still be in there. So as long as your receiver is outputting orthometric heights or mean sea level, then it's actually going into the Z values of the line feature. So all your vertices will be accurate as far as elevations go. But we just don't have our GNSS information, which is a bummer, but it would require something like a related table, something of that kind of setup to capture that information. So that's how we capture the features in Collector. There's some other settings and personal preferences and that kind of thing, but as long as you follow this workflow, you'll know that you're capturing high quality, precise information using an ArcGIS device and Esri's ArcGIS Collector.
Thank you very much for attending today's session. If you're curious to learn more about high accuracy data collection, please come visit me at the EOS booth to ask questions and learn more about this technology. Thank you and have a great summit.